Everyone, welcome to my presentation, Right for the Right Reason, Information Extraction for Trustworthy Tabular Reasoning. I am Vivek Gupta from University of Utah. This is a joint work with Shao Zhang, Alaknanda Mapla, UG He, Tema Georgie from Bloomberg Engineering and Vivek Shikumar from University of Utah. Let's first introduce the task of tabular inference. The task of tabular inference is similar to standard NLI, but here the premise is basically a tabular data, and the task is to given this premise table and a hypothesis statement, we have to determine if the hypothesis statement is true, false or undetermined, that is entail, contradict or neutral. For example, in the right you can see there is a table about a sport dressage, and then there is a hypothesis statement, both men and women can compete in the complex sport of dressage. The model has to predict that this statement is entail given the table. We introduced this task as a part of our prior work in ACL 2020 info tabs. Now the problem with existing model is, let's revisit our example. Now you can see both men and women can compete in the complex sport of dressage. To establish this statement is entail, a model need to look at the correct evidence, that is the relevant rule, and it also need to do the correct reasoning. For example, in this the model has to know that both men and women is related to the key mixed gender and contactless is related to the key contact in the sports. Then it also has to see both men and women can compete, that means the mixed gender should be yes, and contactless mean that the contact and value should be no. Now current black box model doesn't provide the highlighted evidence and the reasoning step required. In this paper we focus on basically how do we get the highlighted evidence as a part of our reasoning approach. Now recently another work which is also presented here, a tackle paper, systematic tabular probing. We show that when a systematic perturbation is done on the table, for example if we remove the key contact from the table, then the model prediction should go from entail to neutral, but we found that it doesn't happen that often. There are many cases where the model really fails. This further highlights the importance of getting the right evidence in the reasoning steps. So we argue it's not enough for the model to be merely right, but also it must be right for the right reason. Therefore, identifying the relevant elements of input as the right reason is very essential for tabular reasoning. Overall, a contribution of the paper is, we show that tabular reasoning model ignore the evidence table rules. We argue that the model should not be just right, but also right for the right reasons. We did a case study on the InfoTab dataset. We converted the task of tabular reasoning to trustworthy tabular reasoning. That trustworthy tabular reasoning basically converted the inference task to evidence extraction plus inference task, a two-step sequential process where first step is evidence extraction followed by the natural language inference task. We saw that this tabular reasoning approach has two benefits. First, it makes the model trustworthy, and second, it also benefits the downstream performance in the reasoning task. Now first look at the evidence extraction phase. In the evidence extraction, what we want is the model prediction should not be just the inference label but also the evidence rule. For example, the same example, both men and women can compete in the contactless sport of dressage. The model should also predict the rows, mixed gender and contact as a part of a prediction pipeline. We first check how does the human perform on this task. To do that, we use Amazon Mechanical Turk and ask human crowdsourced workers to mark all the relevant rows. We give them the premise and the table where each row can be marked. We also include out of table information, especially for the neutral statements, because they may contain information which is out of the table. So we also include that part as a selection process. We found that human really perform very well on this task with the average macro and micro F1 of around 90%. We also found the Fias kappa mean was around 79%, with majority lying in very significant and significant portion. We also find that the exact relevant row matches was from greater than equal to 3 was around 85%, and the perfect F1 score was around 42% with perfect precision and recall of around 60%. Now let's look at approach of trustworthy tabular inference in detail. The first is we have the table. We use the evidence extraction process to get all the relevant rows. This complete are part of the evidence extraction. Then we use the extracted evidence table which only contain the relevant row and the table title along with the hypothesis to do the inference task. This is inference prediction stage. So you can see our process is two step. One is evidence extraction where we extract the relevant rows and then use the extracted evidence, that is the relevant row, to make the inference prediction. Now let's look at some result and analysis from our paper. We tried two approaches for the evidence extraction broadly. One is unsupervised, second supervised. In unsupervised, we tried various approaches like distracting row removal, word mover distance, which are non-transformer based. We also tried some transformer based approaches like sim-align, sim-CSC. For the supervised thing, we basically train a binary classification problem which take each row and hypothesis and predict whether it's relevant or not relevant to the hypothesis. We also use the unsupervised model to create hard negative example for training the supervised model, which I will discuss more later. In the inference prediction, we use the Roberta large model and use the prune premise table along with the hypothesis to make the prediction. Now let us first introduce the dataset. Info dataset has three splits: alpha 1, alpha 2, alpha 3. Alpha 1 contain tables from same domain. They are very similar to the dev and the train set. Alpha 2 has examples which are also from the same domain, but their entail and contradict label are flipped, and these are flipped by minimal hypothesis perturbation, such as making a word over to under or before to after. So these are like adversarial split of the alpha 1 dataset. Alpha 3 contain zero shot setting, where we have table from cross domain which has cleaves which are exclusive of the train setting. First, we tried unsupervised extraction model. So in the unsupervised extraction model, we found that the baseline models like DRR doesn't do very well. They have good recall, that is because they mostly predict 50 to 60% of the rows, but they have very bad precision, hence poor F1 score. Then we tried DRN and alignment based approaches, where we found that it really helped and improved performance. We found that if we use re-ranking and dynamic top K, where re-ranking is basically exact matching of the keys and hypothesis is used to upscore the premise rows which have similar tokens to the keys, and dynamic case, instead of predicting top 4 exactly, we predict top 1 or top 2 based on a varying threshold for each depending on each hypothesis and the premise table. If we use these two techniques, we found that our precision and F1 score further improved. However, we don't find very significant improvement in the alpha 3 zero shot case, which is hard. Then we also tried transformer models. Here we found that transformer further improved the performance on alpha 1 and alpha 2. We also made one more trick. We tried to confound the factor of title similarity. For that, we do hypotitle switch. Again, here also we do re-ranking and dynamic top K to push the model performance. Lastly, we use some kind of a distance supervision with the MLI data, where we use the MLI entailment and contradict pair has a positive and neutral has a negative example for contrastive learning, and this supervision can really push the performance for all the three alpha 1, alpha 2, alpha 3 sets. However, despite improvement in performance, we found that we are still far away from the human extraction baseline. Therefore, we try supervised approach, and in the supervised approach, it's try to close the gap between the human extraction, especially for the alpha 1 and alpha 2 set. We found that using the hard negative approach, where basically we take the unsupervised example which seem relevant to the unsupervised model but are not relevant according to the human for training, and this hard negative example really make the model learn better. And we found that using hard negative up to 3 times the relevant rows is beneficial. However, humans still outperform, especially on the alpha 3 setting. Next, we look at the inference task. For the inference task, we first look at the re-ranking and dynamic top K effects. We found that it doesn't have any substantial benefit in the inference task with re-ranking and dynamic effect. The benefit for the alpha 3 was decent, but for alpha 1 and alpha 2 the benefit was not significant. However, when we use extraction and supervised approach, we found that all the models substantially improve, and there is huge performance, especially for the alpha 3 and adversarial set. Lastly, we check how if the human is doing the extraction. So if human extract the relevant row and then we use that relevant row for doing the inference, the performance should drastically, very especially for the alpha 3 settings. However, despite all this, we found that the human performance of direct NLI with directly predict the inference label without going through the extraction phase is still significantly better, especially for the alpha 3 setting. Overall, the takeaway from the talk is the tabular reasoning model ignore the table evidence rows. We argue that the model should not be just right but also right for the right reason. We did a case study for infotabs. In the case study, we show that tabular reasoning approach should be replaced with trustworthy tabular reasoning, where the inference task is replaced with evidence two-stage pipeline, where there is the evidence extraction followed by the inference task. There are two benefits of trustworthy tabular reasoning. First, it makes the model trustworthy, and secondly, it benefits the downstream reasoning task. I invite you all to my talk as well as the poster session to know more about this paper, and I also request you to go through our paper for more details. Thank you.